So let's go to solve these questions. This question is about energy in a capacitor. So I have a capacitor that is being charged with the amount of charge Q0. Of course, someone has charged the capacitor, maybe a battery, and it makes in one plate, it makes the amount of charge Q0, and the other plate is the amount of charge minus Q0, and they store energy, and the amount of stored energy is U0, and it's Q0 by V0. This is the amount of stored energy, because we saw that in charging a capacitor, from the state minus Q plus Q, you have two plates and you displace the charge ddq0 from one charge to another charge. You start charging the capacitor and you place more charge here, and more charge here, more positive charge in these plates, and the other more negative charge in the other plate, and you start charging the capacitor. We have done the calculation of the potential energy that you store, and the calculation was that U was 1/2 Q squared divided by C. So we are going to use, instead of this equation that is easy to follow also, because on this equation, if we try to use this equation, we can use this equation also. How you will do this equation? You will write like this. The energy stored is 1/2 Q0 divided by Z0. Now, this is the energy that is stored initially. When you insert the dielectric, a substance with K constant dielectric, what happened to the capacitance? The capacitance C0 go from C0 to K times C0. The capacitance increase in a factor of K. So what happened with the energy? So the energy, the final energy, now U will be 1/2. Q0 will not change because are the charge that are on the plates. So it will not escape because here there is like an insulator that prevents the charge to escape. 1/0 divided by the new capacitance. The new capacitance is K times the old capacitance. So the new U will be 1 divided by K, 1/2 Q0 divided by Z0. But this amount is the old energy without the capacitor. So the new potential energy will be U0 divided by K. Well, this is one way of seeing using this equation, but of course you can use this equation also. If you use this equation, you have to understand that the difference in potential is E0 by D. Now what happens when you insert a dielectric? When you insert a dielectric, the electrical field is changing by a factor of K. So if you introduce the change here by E0 by K, you will see that now the new potential energy is stored in the capacitor with the dielectric inserted is a fraction of the old stored energy without the capacitor. So because K is bigger than 1 divided by K is smaller than 1. So what is bigger? U is bigger than U0, or U0 is bigger than U? Of course, if K is bigger than 1, this is the correct solution, okay? U0 is K times U. So 2 times U is U0. So U0 is bigger than U. Okay? Correct? In this problem, initially we have a charge Q0, and we have the distance D0, and we have that the potential energy is U0, and U0 we know that is 1/2. I can use Q by V, but maybe better I will use something that implies the capacitance. Because the capacitance is C by V, this will be C by V squared. So U0 will be 1/2 the capacitance C0 by the difference in potential V0 squared. Now what they say is the separation D0 is equal to the double, 2 times D0. What happened with the potential energy stored? So we'll need to see what happens with the capacitance and what happens with the potential. The capacitance C is the capacitance C. Here there is no dielectric that we insert. Only we change the distance D0. The capacitance is epsilon 0 A 0 divided by D0. This is the initial capacitance. The new capacitance will be epsilon 0, A0 have not changed, to D0. So the new capacitance C will be 1/2 of the old capacitance. So the new capacitance will be 1/2 C0. Do you agree? Yes?
Yes.
Okay. But now, if I use this equation, I need to know what happened with V0. E 0 by T is V0, is the change in potential. Now, the new V will be E0 will change. E0 is the electrical field produced by the charge. So E0 is the new all electrical field. The all electrical field is equal to the new electrical field. Even if you change D0 from 2 D0, the electrical field will not change because the area of the plates and the charge of the plates have not changed. So in this case, the change in potential will be E0 by 2 D0, will be 2 times E0 by D0, will be 2 times the difference in potential. As a conclusion, the potential double when you change the distance D0. So what happened, and the problem asking what happened with the potential energy. So the new potential energy, U will be 1/2 C by V. The new capacitance will be 1/2 of C0, and the new potential will be double. But if you make the calculation, double of square will be 4 times. So at the end, the capacitance will be, the potential energy stored will be the double of the initial potential energy. So changing the distance D from D0 to 2 times D0 makes a change in the potential energy stored that is a double potential energy. Okay, this problem, these questions, I'm going to do it in a separate video. Let me go to the next one. The next one is solved here. It says that you have a 6 microfarad. Initially, you have a 6 microfarad capacitor, so you have capacitor is charged by the battery of 100 volts, so the battery will plug charge on the capacitors. The capacitor will have a different in potential. Of course, it means that it has an electrical field. Delta V will be E by D. So it say like this. It say if you put a dielectric of constant K equal 4.5 into the capacitor of 6 microfarad, what will be the new charge? The new charge. So the new charge will be if you maintain fixed the potential here, the new charge. I did this problem in one of the modules, but if you maintain fixed the potential, the new charge will have to be increased in a way that the electrical field inside here will make possible that E by D will be the difference in potential. So E by D will be the difference in potential. So what I did here is, first of all, I calculate the initial charge. I don't know why. Well, yes, I know why. I calculate the initial charge. The initial charge before the dielectric is plugging on is the capacitance by the difference in potential. So the initial charge is 6 by 10 a la minus 4 coulombs. So the charge that will be on the plates is the charge that will make possible to the electrical field that is being reduced inside the capacitor, inside the volume of the capacitor, by the dielectric will be create an electrical field that the difference in potential will be equal to 100 volts. So you need to, the battery need to put more charge into the plates of the capacitor, and the amount of charge that it needs to make this possible is K by Q0. So you can see, for example, from this equation, is 100 is the initial difference of voltage. That is 0 by 0, that is maintained constant. So it will exist an E0 that will be V0 divided by D0. Okay, if now you place another a dielectric, and you maintain fixed the V0 and you maintain fixed the D0, but the electrical field will not be maintained constant because the electrical field is being amortiguated, it's being reduced by a factor of K. So it means that you need the charge to go to the plates in an amount K times Q0 to produce an electrical field that will compensate this decreasing. So this is the Q, and what I did here is, well, I calculate the Q. I calculate the Q. The new Q will be this amount. The new Q will be this amount. If you read carefully what the problem is asking, what is the additional charge? The additional charge was the old charge, the difference between the new charge that you have found, K times the old one minus this one. So this is the additional charge. Let's go to see this one. And this problem is capacitor in combinations. Well, it's easy. You can draw this problem from A to V. I have drawn this problem like this problem like this, from A to V. From A to V. This is the same point A. Starting, I found the 2 microfarad. Now the point C, when you arrive to the point C, this is the point C, Okay, this is the point C. When you arrive to the point C, you will find for one part the 6 microfarad and the other part the 4 microfarad, and now you will be at the point B. So between A and B, there is a capacitance. What is the equivalent capacitance of this? Well, you have these two in parallel connected with this one in series. If you connect in parallel, the C equivalents connected in parallel will be 6 plus 4, that will be 10 microfarads. Connected with the 2 will be now in series. So you will have 2 capacitors, one of 10 microfarad, one of 10 microfarad, and the other one of 2 microfarad, and the equivalent capacitance is 1 over C equal 1 over C1 plus 1 over C2. So if you calculate, the C equivalence will be C divided by 3. And the last one that we did is to answer these kind of questions that say you have a capacitor with charge Q, you maintain the charge Q constant, so you put an insulator to avoid the charge to escape from the square plates, and you pull the plates apart, twice the original separation. Which one of the following statements are true? The energy stored in the capacitor has doubled. Yes, you can calculate the energy, and the initial energy stored will be 1/2 Q0 by V0. So 1/2 Q0 is 0 by D0. But when you increase the distance to D0, the charge Q0 will not change, but the potential will change because the potential is E0 by D. So it will be 0 by the distance to D. So it will be 2 times Q0 is 0 by D0, so it will be 2 times U0. So this is true. The electrical field between the plates can have increased. Well, if the area become the same one, and the charge is exactly the same one before and after, there is no change in the electrical field. The electrical field is produced by the charge, so if you don't change the charge, well, you don't change the electrical field. The capacitance has doubled. No, the capacitance is half of the all capacitance. Why? Because the capacitance is epsilon 0 A0 by D0. Now A0 will not change, so the new capacitance will be epsilon 0 by A0 by 2D0. It has changed the distance 2 times, so the new capacitance is 1/2 of the old capacitance A0 divided by D0. So the new capacitance is 1/2 of Z0. So this is false because it has not doubled. The capacitance has been reduced in a factor of 2. The energy density in the capacitor has increased. The energy density, the density of energy is 1/2 epsilon 0 E squared. Well, if E have not changed, the density of energy has not changed. But the total energy has doubled, because the total energy is the density of energy per unit of volume. This is the energy per unit of volume, but now the volume has doubled. So that's why the energy, the density of energy by the new volume is the total energy. So you can see like this, the density of energy has not changed. The volume has changed to the double. So now the potential energy has changed to the double, because it will be 2 times rho 0 by the volume. This is volume, okay, volume, not potential. So it will be 2 times U0. So we can find again the same thing for the answer of these questions. So the energy density of the capacitor has no, this is not true. The density of energy has been constant. Only the total energy has increased to the double. And the potential energy across the area has doubled. Yes, we have seen at the beginning this term. If you make it double, well, you double the potential energy, okay? Delta V. So that's all. Oh no, there is one. We see there is one more question here. So, oh no, this is not a question. This is a derivation. Okay, that's all.